Modern computers can do billions of instructions a second. With the techniques we've discussed so far, it would be hard for a program to run for more than a tiny fraction of a second. Practically, we're not going to type out millions of instructions to keep the computer busy. If we're going to have useful work going on for a longer time, we need repetition, where code is used over and over. There are two Python statement types that do that: the simpler for loops, which we'll take up in just a moment, and while loops, which come several chapters from now. Before we get to that, there are several preliminaries. First of all, updating variables. We did that some when we were just working in the shell, but I don't think we've done it in any programs. So here's a very simple sequential program that updates variables, setting x to 3, y to x plus 2, and then we change the value of y, change the value of x, and print the result. It's going to be very important to be able to follow the sequence of changes to variables accurately. I have a way of helping that out. I use a table to follow things. Here we can't really see the original program the way I have it, so let me bring in another version. So the idea of this table here is that we give the line number of the instruction, which you see I list up here, and the variables that have the potential to be used or changed, and I also leave a space for a comment. Now in this particular instance, we're just going to go through the lines sequentially, so the line numbers aren't real important, but when we get to loops, we'll see they become, and function calls and things that become much more important. So let's just follow this through quickly. Line 1 sets x equal to 3, so after line 1, x is 3. Dash here means y isn't set yet. Second line, y equals x plus 2. Well, we look above line 2 and see what was the value of x at the current time, and it was 3. So it's 3 plus 2 equals 5, and that's the new value of y. Then we go on. That was line 2. Line 3 follows immediately after. Y is assigned the value of twice the current value of y. We're in line 3. So we look back and see that after line 2, y was 5. So it's 2 times 5. The result is 10. This then becomes the new value of y. On to the next line. Similarly, x becomes the old value of y minus x. And here in line 4, the old value of y is 10, the old value of x is 3, 10 minus 3 is 7. That becomes the new value of x. And in line 5, we just print the current values, which are, of course, 7 and 10. I call this approach of consciously following through line by line of execution playing computer. And we will use it as a technique to check for errors frequently. Let me go on now to the list type. We've mentioned this briefly. Explicit lists are enclosed in square braces, square brackets, and are a comma-separated list of values. It can be any kind of type or even mixed types. Now the range function. Some particular lists that we particularly want to generate are lists of the first few whole numbers. Let's try this out. Okay, so for instance, list range 5. And what this gives us is the first 5 whole numbers. Particularly, there are 5 elements, and it starts with 0, first whole number, so it only goes through 4. That's the important thing to see here. So the general pattern here is this generates a sequence, the range function, and you say the size of the sequence, and they become, in this form, it's just a sequence number starting at 0. We'll see fancier versions of this later.